Please write. Find the accelerations of the following objects. Find the accelerations of the following objects. Full stop. Find the accelerations of the following objects. Roman number 1. Let me give you a very simple question. That is the 4 kg mass. It is given that the surface is smooth and we have applied the force of 16 Newton. Draw this figure. Try to find the acceleration. Start. It's very simple, right? Let's just apply F equals ma. The force acting on this object is 16. The mass of the object is 4, acceleration is a. If you take 4 to this side, 16 divided by 4 equals a. Then a equals 4 meter per square seconds. Who got this answer? It's so simple, right? Who got this answer? Right. The second question, Roman number 2. There is an object. Mass is 10 kilogram. Mass is 10 kilogram. Now the surface is rough. A rough surface. What does it mean there? What is the meaning of the surface is rough? The surface is
no friction.
Yes, very good. The surface is rough mean there are friction forces. The friction forces are given by the surface. That's the meaning of surface is rough. That's the meaning. Right. So let's apply. Let me mark the force applied on the object as 12 Newton. So there is a friction force. There is a friction force. Fri. Let me mark the friction force as anything. Let me mark the friction force as 8 Newton. So draw this figure and find the acceleration. Draw this figure and find the acceleration. So this 8 Newton is the friction force. The first 2 questions, they are very simple. I just wanted to revise the theory. I just wanted to revise the basics. Is video clear? Is audio clear? Please tell me.
Yes, sir.
Sir. Yes, sir.
Yes, sir.
Right, thank you. So let's apply F equals ma to this object and let's find the acceleration. So we apply F equals ma to this object. There are two horizontal forces. The first horizontal force is 12 Newton. There is the oppositely directed force, that is the friction force. The mass of the object 10, we don't know what the acceleration is. We are going to find the acceleration. So 12 minus friction force is 8 equal 10 into 8. 12 minus 8 is 4 equals 10 into 8. Take 10 to this side. 4 divided by 10 equals A. Therefore, A equals 0.4 meter per square seconds. Who got this answer? Who got this answer? Okay, let's go to the next question. Put number 2 and write question number 2. An object is moved on a rough horizontal surface. An object is moved on a rough. Second question. First question, Roman number 1, Roman number 2, we completed. Now second question. An object is moved on a rough horizontal surface as shown in the following figure. An object is moved on a rough horizontal surface as shown in the following figure. An object is moved on a rough horizontal surface as shown in the following figure. Right, please draw this figure here. Still, I didn't give you the question. Just draw the figure and wait. I have given the external force as 40 Newton. I have marked the friction force as FRIC. I have marked the acceleration, but there are few other things to be marked. Please draw the figure and wait until I give you the questions. In addition to these two forces, there must be another two forces. What are the other two forces that should be marked on the figure here? Somebody unmute the mic and tell me.
Weight and normal force.
Normal reaction.
Yeah, very good. What are the two forces, dear? The gravitation attraction force given by the earth, mg. What is the famous term, dear? Normally we call this as, please mark this as gravitation attraction force. But what is the famous term, dear?
Weight, sir.
Weight of the object. Very good. Gravitation attraction force, the scientific term, but it is widely known as the weight of the object. It is mostly known as the weight of the object. So this force is given by the earth. Who gives this mg force, dear? Unmute the mic and tell me who gives this mg force. Hello?
Earth, sir.
Sorry? Yeah, you correct. You are correct. Talk to me,
By
dear.
earth.
Who gives this mg force?
By earth, sir.
The earth.
By
Gravity of the earth. Why are you afraid to talk to me? The gravity of the earth, yes. Then who gives this R force, dear? It is this R Newton force is perpendicular to the surface. R force is perpendicular to the surface. Who gives this R force? Somebody please tell me.
Surface.
Very good. R force is given by the surface. R force is given by the surface. Why it is called normal reaction force? Why it is called normal? Somebody?
Normal
Why
to the
is it
surface.
called normal? In physics, normal means perpendicular. You see, this angle is 90 degree. 90 degree is said to be perpendicular. Perpendicular is said to be normal. So in advanced level physics, normal means 90 degree, perpendicular. R force is perpendicular to the surface and R force is given by the surface. Therefore, it is called perpendicular reaction force. Without saying perpendicular reaction force, it is said normal reaction force. Please mark them all. Mark them all. Normal reaction force. Mark them all. You should know the theory here. You should know the story, right? Without, if you just do calculations without any understanding, that is useless. You should do all the calculations with a full understanding. That's what I want from you. Right. Now you know these things. mg force is given by the earth, by the gravity of the earth. Therefore, mg force is known as gravitation attraction force. Capital R force is given by, I should name, capital R force is given by the surface. The surface. Capital R force is given by the surface. And capital R force is perpendicular to the surface. So as it is perpendicular, it is said to be normal. Normal and abnormal. Right. Okay. Now we have ability to add about 500 students. So it will not be a problem because last few weeks, some of the students were not able to join to the class. So today we have solved that problem. Right. Please complete everything. Please write down everything, mark all the things. After that, I'll give you the questions. Have you heard this name earlier? Have you look at board? Don't write. Don't write. Just check whether you have heard this earlier or not. Have you ever heard this term? Normally, this is denoted by mu small k. Who has heard this name earlier? Anybody in the class? If you have joined to my Sunday morning paper class, the free paper class, you may have heard, but I think in O levels you may have not heard, right? Right. Now we are going to play with friction. It will be very interesting game. Yeah, it will really be interesting. You will really be happy. Right, Roman number one. Roman number one. I'm going to give you a few questions. Roman number one. Find the friction force acting on the moving object. Find the friction force acting on the moving object. Moving object. Within brackets, the coefficient of kinetic friction. The coefficient of kinetic friction is, look at board, the coefficient of kinetic friction is 1 over 4. Look at board and write. Coefficient of kinetic friction is 1 over 4. The coefficient of kinetic friction is 1 over 4. 1 over 4. Okay. Roman number 2. Roman number 2. Find the acceleration of the object. Find the acceleration of the moving object. Right. Now I am going to explain everything. If you have even never heard Newton's laws of motion, you will understand everything. Why? I'm going to explain everything. Right. So what are the two questions? Roman number one, find the kinetic friction force acting on the moving object. Within brackets, the coefficient of kinetic friction is 1 over 4. Roman number 2, find the acceleration of the object. Who would like, if I repeat the questions, dear? Anybody in the class? Anybody in the class?
Yeah. Yes, sir, please. The Roman number one question.
Roman number 1, find the friction force acting on the moving object. Roman number 1, find the friction force acting on the moving object. Within brackets, look at board and write, the coefficient of kinetic friction is 1 over 4. The coefficient of kinetic friction is 1 over 4. Okay, dear? Right. Now let's write some descriptions before we answer the questions. Right? We are going to write some descriptions. We are learning. We are not doing a paper, and this is not a paper discussion class. We learn. We gather theory. Listen carefully. Write in point form. Write in point form. If you want, you can put some star points. Right. The first star point. Mg force is given by the earth. Look at board and write. Mg force is given by the earth. Mg force is given by the earth. Full stop. Mg force is given by the earth. Full stop. That continue. That force is known as. That force is known as. That force is known as gravitation attraction force. Gravitation attraction force. That force is known as gravitation attraction force. That force is known as gravitation attraction force. Full stop. Continue. Sometimes mg force is said to be, sometimes mg force is said to be the weight of the object. Sometimes mg force is said to be the weight of the object. Sometimes mg force is said to be the weight of the object. Now somebody unmute the mic and read that star point from the beginning to the end.
mg force is given by the earth. That force is known as gravitation attraction force. Sometimes mg force is said to be the weight of the object.
Very good. Thank you very much. So I have practiced, I have trained my students to help other students. So we build not only the knowledge, but also good humans qualities. So when you help other humans, even God will help you back. Right? Who would like to hear the star point again? Who wants further help?
Yes, please again.
Okay, somebody please read the note star point again. Somebody.
May I?
Yeah, please don't ask permission, dear. Please read once. You are always given the permission.
mg force is given by the earth. That force is known as gravitation attraction force. Sometimes the mg force is said to be the weight of the object.
Right. Thank you. Who would like to read one another student? I would like to hear from another student.
mg force is given by the earth. That force is known as gravitation attraction force. Sometimes mg force is said to be the weight of the object.
Very good. 3 students helped us. We are very much grateful to them. Next star point. Capital R force is given by the surface on which the object is kept. Capital R force is given by the surface on which the object is kept. Capital R force is given by the surface on which the object is kept. On which the object is kept. Full stop. Capital R force is perpendicular to the surface. Capital R force is always perpendicular to the surface. Please use the term always. Capital R force is always perpendicular to the surface. Capital R force is always perpendicular to the surface. Full stop. Therefore, capital R force is said to be, use a different color pen and write, capital R force is said to be the normal reaction force. Capital R force is said to be, capital R is said to be the normal reaction force. The normal reaction force. Got it? Would like if I repeat it? Right. Now I'm going to ask you a question. Look at board, dear. Look at board. Let me mark R force. Let me mark R force. And let me mark mg force. Let's say mg is 100 Newton, R is 90 Newton. Then what will happen to the object? Will it be moved up or will it be moved vertically downward?
Moved vertically down, sir.
Vertically downwards, sir.
Very good. Correct. As mg force is larger than r's force, maybe surface is weak surface, so it can be broken and moved down. So if mg force is larger than r, the object will be moved downward. Why? 100 Newton greater than 90 Newton, so it will be moved down. Now, what will happen if r is 190 and mg is 100 Newton? To which direction that the object
It
is
will move upward.
Very good. The
The
object
object
will
will
be
move
moved.
upwards.
The object will be moved upward. Very good. Third question. What will happen if R is also 100 Newton?
It will be object won't move, sir.
It will be at rest, sir.
Be careful. Think again and tell me. If R is 100, mg is 100, what will happen to the object? It is, will it be moved up? Will it be moved up?
No, sir.
No,
Will
sir.
it be moved down?
No,
No.
sir.
No. So the object will not be upward and the object will not be moved downward, but we cannot say object is at rest. Why? Object is not moving upward.
Constant velocity.
Object is not moving downward, but we can't say that object is at rest. Why? Think.
So there may be
It can
horizontal
move
forces.
horizontally.
There is a horizontal force. There is a horizontal force of 40 Newton. Because of this 40 Newton, the object is moved along the horizontal direction. There is an oppositely directed friction force also, I agree. But as the external force, force 40 Newton is greater than the friction force, the object will be moved into the horizontal direction. Clear? Yes or no?
Yes, sir. Clear,
Yes,
sir.
sir. Yes, sir.
Clear, sir.
As R and mg forces are equal, there is no vertical motion. Object will not be moved up, object will not be moved down. But when the horizontal forces are considered, 40 Newton force is larger than the friction force. Therefore, object will be moved into the 40 Newton force direction along the horizontal direction. Clear? Would like if I explain the story again? Anybody in the class? You can raise your hand up. Right. So please write. As R force is, yeah, let's write the description. Let's write the description. After that, I'll give you another description. Let's write the note. Star point. As R force is, star point, as capital R force is equal to mg force. As capital R force is equal to mg force, comma, the object does not have any vertical motion. As capital R force is equal to mg force, comma, the object does not have any vertical motion. As capital R force is equal to mg force, there is the object does not have a vertical motion. The object does not have a vertical motion. Within brackets, the object is not moving upward or downward. Within brackets, the object is not moving upward or downward. Right. Who would like if I repeat that star point?
Sir, please.
Yeah. As capital R force is equal to mg force. As capital R force is equal to mg force, comma, the object does not have a vertical motion. The object does not have a vertical motion. Within brackets, object is not moved upward or downward. The object is not moved upward or downward. Okay? Okay, dear?
Okay, sir. Thank you.
Right now, please draw this figure once again. This kind of a figure has a special name. What is the name that we given to this kind of a figure? Somebody unmute the mic and tell me. What is the name of this figure?
Free body diagram.
Free body diagram or
Free
free force
body
diagram. Very good. This is called a free body diagram. Free body diagram or free force diagram. You can use any of these terms. Draw this figure and use a curl bracket and name it as free body diagram or free force diagram. Do it. Draw it. Draw it, dear. Did you draw the figure? Please tell me whether you have drawn the figure or not.
Yes, sir.
Right now, as there is no vertical motion, as the object is not moving up, as the object is not moving downward, I can use another curl bracket like this and I can write R equals mg. As object is not moving upward, as it's not moving downward, R and mg forces should be equal. M is given as 4 kilogram. Value of G is 10. Therefore, R is 40 Newton. So we have found the normal reaction force as 40 Newton. Clear? Continue. Complete the knot. Right. So a next star point. Please write the next star point. Next star point and write. It is given in the question that, next star point, it is given in the question that the object is moving. It's given in the question. It is given in the question that the object is moving. Therefore, it is given in the question that object is moving. Therefore, the horizontal external force. Therefore, the horizontal external force should be greater than the friction force. It is given in the question that the object is moving. Therefore, the external horizontal force should be larger than the friction force. The external horizontal force should be larger than the friction force. Is it clear here? Is it clear or not? Hello? Can you hear me?
Yes.
Yes, sir.
Yes, sir.
Yes. Is audio lagging or is audio clear?
It's clear.
It's clear, right?
Clear, sir.
If audio is not clear or video is not clear, the one of the main reason is your device may be very hot. So especially, listen dear, I always take the video call by using my mobile phone, right? So the best thing is, if your video and audio is not clear, remove the cover. Because then the temperature of the device will be lower. So if you use a plastic or any cover, there is no way to lose the heat to the surroundings. So device will be very hot. So therefore video and audio will not be clear. That's the first reason. And the second reason is this. If you use a router, for classes, for the data, completely useless. Routers always give a very low video and audio quality. I don't know the reason, but it should be better. So I have thrown them away both, right? So best thing is using mobile data. In mobile data, in most of the places, Hutch is better. Hutch and Airtel are better. Hutch is the best for mobile data, as I have experienced, right? So try to do these changes. And if you use a laptop, to join to the class, use a fan. It always needed to be in a lower temperature, right? And the other thing, if you use a router, now you can't change it. Router should also be kept closer to a fan, so it will be at a lower temperature, so it will give you a better service, right? Okay, I think you got an idea. And the other thing is, some laptops will give you low audio. Then you have to use a headphone. I think headphones about earphones about 120 rupees or 100 rupees. So use a set headphone set. It's good. So then you will not hear anything, any surroundings noises. For example, when you are learning, maybe your parents are watching television, or maybe your sister is blaming you. So there may be disturbances. The best thing is use a headphone, clip them, then you don't hear any noises. You will hear only my voice. You will learn properly. Those are the solutions. Okay, don't ask your parents or other people to be silent. It's not practical, because all the 7 days you have class. Just use a headphone. 100 rupees, 200 rupees. Use a cheap one. Right, no need AirPods for online classes. No need Apple AirPods for online classes, right? Okay, somebody please unmute the mic and read the last point that I have given. Unmute the mic and read the last point that I have given you.
It is
It's
given
given in the question that the object is moving. Therefore, the horizontal external force should be greater than the friction force.
Very good. So next star point. The friction force acting on a moving object, the friction force acting on a moving object is known as the friction force acting on a moving object is known as, use a different color pen and write kinetic friction. Kinetic friction. The friction force acting on a moving object is known as kinetic friction. Is known as kinetic friction. Got it? The friction force acting on a moving object is known as kinetic friction. Okay, dear? Right. Next star point. Kinetic friction force can be found by the following equation. Kinetic friction force can be found by the following equation. Kinetic friction force can be found by the following equation. Kinetic friction force can be found by the following equation. Okay? Right, look at board. So this is a new thing. Sometimes you may have learned it in O levels, or sometimes you may have learned never learned. Right. So scientists had done some experiments. We are learning from this question. Sometimes direct learning, sometimes learning from questions are better than direct learnings. Even in our day-to-day life, real life, when we face problems, we learn a lot of things. It becomes a strength. The problems become strength because we learn a lot of things in day-to-day life. So same thing happens here. We learn theory from this question. Listen. So scientists had done some experiments and they have found that friction force is directly proportional to the normal reaction force. Normal reaction force. What scientists had found here? I'll teach you friction separately, right? Because we have to teach static friction, but this is not the time to teach you static friction. So we are just doing the question because I want to go to 600 questions, dude. So scientists had done some experiments. They have found that the friction force directly proportional to the normal reaction force. What does it mean, directly proportional? Can somebody explain me? What's the meaning of directly proportional? So simple. If the normal reaction force is larger, friction force will also be larger. That's the point. Right. What is the meaning of directly proportional? What's the meaning of directly proportional, dear? Kinetic friction force directly proportional to the normal reaction force. It means if the normal reaction force is larger, the friction force will also be a larger one. If the normal reaction force is a smaller one, friction force will also be smaller. That's the meaning of directly proportional. Let me use to indicate friction force friction force FRIC. FRIC directly proportional to the normal reaction force, that is capital R. How do we convert a directly proportional mark into an equation mark? Somebody unmute the mic and tell me. How do we convert
By multiplying by a constant.
Multiplying a constant.
multiplied by? 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 Multiplied by?
A constant.
Multiplied by a constant. So then very good. So friction force equals a constant. The constant that we use here is a Greek letter mu. Friction force equals mu times R. Here this is said to be mu K. This constant mu K, wait, the constant mu K is said to be the coefficient of kinetic friction. The coefficient of kinetic friction. Let me explain again. Scientists had done experiments. They have found that when the normal reaction force is larger, the kinetic friction force is also larger. When the normal reaction force is smaller, the kinetic friction force is also smaller. So it means it is said to be kinetic friction force directly proportional to the normal reaction force. So friction force directly proportional to R. To convert directly proportional mark into an equation mark, one side of the relationship should be multiplied by a constant. The constant is mu k. The constant mu k is known as the coefficient of kinetic friction. So write this and try to remember it. But another day, I'll teach this again. Read and write. Right. Shall we find the friction force, dear? Shall we find the friction force? Let's use the equation directly. Friction force equals mu R. Now somebody unmute the mic and tell me the value of mu. What is mu?
1/4.
1/4. Very good. 1/4. R, what is the size of R? R?
40.
40 Newton. R is 40. Therefore, what is the friction force, dear? Friction force.
10
Newton.
10 Newton. 40 divided by 4 is 10. So we have found the kinetic friction force as 40 Newton. So what is kinetic friction force, dear? What is kinetic friction? It is the friction force acting on a moving object. What is kinetic friction, dear? It is the friction force acting on a moving object. Okay, write it here. Right, now how do we find the acceleration? That's the final target. How do we find the acceleration? Somebody?
F is equal ma.
Yes, we
F
should
is equal
apply
F equals
the equation F equals ma. Let me erase all this. Let me erase everything. Right. Let me erase everything. And along the horizontal direction, along the horizontal direction, along the horizontal direction, don't write. Along the horizontal direction, I apply F equals ma. How many horizontal forces are acting on the object? How many horizontal
Two.
forces acting on the object? Yes?
2.
2. What are the
2,
two?
sir.
Yes, sir.
40 Newton
40 and
and
40
10.
Newton and
10.
this one?
and
Frictional force.
Friction force. Very good. So
10 Newton.
the horizontal external force 40, opposite directed friction force FRIC equal mass is 4. We don't know what the acceleration is. 40 minus FRIC. 40 minus friction force is 10. This is 4A. What is the scientific term that we use to name this 40 minus 10 dear? What is the scientific term dear? What is it called?
Resultant force.
Resultant force.
Resultant force. Very good. This is known as resultant force. I think, please write this. I think no need to draw the figure. No need to draw the figure. Write this and name this as resultant force. Find the value of simple A. Just give me the answer as a fraction. No need to divide. No need to divide. Give me the answer as a fraction, right? So what is acceleration dear? Did you find it? Did you find the acceleration?
15 over 2 ms minus 2.
It is said 15 over 2. Let's see. I'll erase this side and I'll try to find the acceleration. Let me erase it first. Let me erase this first. Right. 40 minus 10. 40 minus 10 is 30 equals 4 times 8. Take 4 to this side. 30 divided by 4 equals 8. So A equals 30 divided by 2, 15. 4 divided by 2 is 2. 15 divided by 2 meter per square seconds. Got it? Right. Who got this answer? Please leave the answer as a fraction here. Who got this answer? Shall we go to the next question? Shall we go to the next question, dear?
Okay.
Okay. Please write example number 3. We can learn a lot of things from examples. Example number 3. Please write. A metal box is moved on a rough horizontal surface. A metal box is moved on a rough horizontal surface as shown in the following figure. A metal box is moved on a rough horizontal surface as shown in the following figure. A metal box is moved on a rough horizontal surface as shown in the following figure. Rough mean there are friction forces. A metal box is moved on a rough horizontal surface as shown in the following figure. Draw this figure here. Please draw the figure. The external force applied on the object is 200 Newton. There is a friction force. There is a friction force. So let me mark this as FRIC. The object is moving. The object is moving with an acceleration of 2 meters per square seconds. 2 meters per square seconds. Right? The surface is rough. A rough surface. A rough surface. Somebody please unmute the mic and tell me the name that should be given to this friction force. What is the name of this friction force here?
Kinetic friction.
Kinetic friction force. Why? The object is moving. The friction forces acting on moving objects said to be kinetic friction. So therefore, as the object is moving, you see it has an acceleration. It has an acceleration, so it means it's definitely be moving. So the friction force acting on a moving object said to be a kinetic friction force. A kinetic friction force. A kinetic friction force. Draw the figure. After that, I'll give you the questions. First of all, draw the figure. Then I'll give you the questions. Please don't chat with the students in the group, right? When I'm teaching, don't chat with the students in the Zoom. So if you do it, I have to disable the chat section. Okay, dear. So please don't do it. So if you want any information, just the best thing is you can send a message to WhatsApp group, and never send personal WhatsApp messages to any of the students in the class. So because you see that WhatsApp's group is message is allowed. So it means if once you have a problem, send a message to the group. So someone in the group will reply you. Clear? Do not send any personal message, and especially when I'm teaching, do not use the Zoom chat to chat section to chat with the students. It's not a good habit of a learning student. Right. Roman number one. Roman number one. Find the friction force acting on the object. Roman number one. Find the friction force acting on the object. Find the friction force acting on the object. Roman number two. What is the size of the normal reaction force? What is the size of the normal reaction force given by the surface to the object? What is the size of the normal reaction force given by the surface to the object? What is the size of the normal reaction force given by the surface to the object? Roman number three. Roman number three. Roman number three. Draw the free body diagram of the object. Draw the free body diagram of the object. Draw the free body diagram of the object. Final question. Final question. Calculate the coefficient of kinetic friction. Final question. Calculate the coefficient of kinetic friction. Calculate the coefficient of kinetic friction. Right. Who would like if we read the questions again? Anybody in the class? Right.
So the first
Yeah. Jumana, read the questions that you have written. After that, I'll read the questions that you have missed. Jumana, please unmute the mic and read the questions that you have written here. Evini, can you read the questions that you have written?
Find the friction force acting on the object. Second one, what is the size of the object? Third one, draw the free body diagram of the object. Fourth one, calculate the coefficient of the kinetic.
Very good. Thank you very much. Who would like to read the question once again? Another student, please help. One student helped us. Another one, please read all the questions.
Question. Find the friction force acting on the object. Second question. What is the size of the normal reaction force given by the surface to the object? the surface to the object. Third question, draw the free body diagram of the object. Fourth question, calculate the coefficient of kinetic friction.
One more student, please read all the questions. Two students helped us. Third one, please one more student read the questions.
Find the friction force acting on the object. What is the size of the normal reaction force given by the surface to the object? Draw the free body diagram of the object. Calculate the coefficient of kinetic friction.
Right. So thank you, dear. Three students helped us. Now, how they given us the value of mu? Is it given in the question or not? Somebody please tell me.
Not given, sir.
Not given, sir.
It is not given. When the value of mu is not given, do not use this equation to calculate the friction force. Why? If you don't know mu, you can't find friction force. Mu is not given. So we cannot use this equation to find the friction force. Then how do we find the friction force? Somebody?
By using F
F
equals
equals
ma.
ma.
Yes, very good. If we can't use this equation, the easiest way to find the friction force is applying F equals ma. Look at board. I apply F equals ma equation horizontally. How many horizontal forces are acting on the object here? How many horizontal forces? Two horizontal forces, 200 and friction. Therefore, the resultant horizontal force into the right hand side direction is 200 minus FRIC, friction. Mass of the object is 10, acceleration is given as 2. 200 minus friction force equal 2 times 10 is 20. Plus 20 come to this side as minus 20. Minus friction force goes to the other side as positive friction force, and 200 Newton remains unchanged. What other things happen? Positive 20 come to this side as negative 20. Minus goes to other side as positive. So finally, we got the friction force as 200 minus 20 means 180 Newton. The friction force is equal to 180 Newton. Write this, dear. Write it down. Right. What is the second question, dear? Somebody read Roman number 2.
What is the size of the normal reaction force given by the surface to the object?
Right. Third question, dear. Please read 2 and 3 both.
Draw the free body diagram of the object.
Right. Let's answer 2 and 3 questions together. Look at board. Let me answer. Even you are able to do this kind of things even in the examination, right? So let me answer Roman number 2 and Roman number 3 together. Right? So let's draw the free body diagram. There are two horizontal forces, the 200 Newton external force, the friction force, kinetic friction force, and the gravitation attraction force given by the earth, mg Newton, and the normal reaction force given by the surface. Right? Object is not moving up, object is not moving down, because upward force and downward force equal. It means R is equal to mg. So R equals mg. M is given as 10 kilograms. So M is 10, G is 10. Therefore, normal reaction force is 100 Newton. But object is moving to the right hand side with an acceleration of 2 meter per square seconds, because 200 Newton force is bigger than the friction force. It is said that object is moving. For the object to be moved, definitely 200 Newton force definitely be greater than the friction force. That's why it is moving to the right hand side. Got it? Draw this figure. Use a curl bracket like this. If you have any doubt related to this part, please ask me. Start. Okay, what is the next question, dear? Somebody read the next question. What is the next question? Read.
Calculate the coefficient of kinetic.
Calculate the coefficient of kinetic friction. Now it's so simple. So simple. Roman number 4. We know that kinetic friction, kinetic friction force. Kinetic friction force is equal mu k times r. Mu k times r. We have found kinetic friction force as 180 Newton. 180 Newton. Mu k we don't know, but r, normal reaction force, is 100. If you take 100 this side, you will get 180 divided by 100 equals mu k. So 180. What is the unit of this 180? What is the unit of this 180? Somebody
Newton.
please tell me.
Newton, sir.
Newton, sir.
Newton, sir. Friction force. Therefore, unit is Newton. What is the unit of this 100?
Newton.
Sir.
Newton, sir.
Then what is the unit of mu k?
No
No
unit,
unit,
sir.
sir.
No units. Newton to Newton cancelled out. Mu k does not have units. 0, 0 cancelled out. 18 divided by 10 is 1.8. No units. No units. Got it? Write it. So please remember that the coefficient of friction, whether it is kinetic or static, the mu does not have units. Mu k, right? Mu k. Mu is a Greek letter, k is the English letter. Okay, did you write everything? Do you have any doubt related to kinetic friction, dear? You have any doubt related to kinetic friction? If so, send a
Excuse
message
me,
to the
sir.
Zoom chat. Yes, dear?
Sir, is kinetic friction and dynamic?
Same. Kinetic friction, dynamic friction, same, dear.
Okay, sir.
Right. And the other thing is the replies to WhatsApp chats, even from me and from the two admins, will be late because many students are talking to them. It means 21 batch, 22 batch, 23 batch. There are three different students. At least you think at least if there is at least 200 students in one group, so it means normally they receive about 600 messages per day. So most of the time there will be a delay in reply. But even with the delay, they will reply, including me, right? I am also very late to reply. Right? So because many people send messages. So if a reply is delayed, the best thing is send me a message to my WhatsApp. So then I can handle the case personally. Right? I think I'm a little bit faster than the two admins. I think my replies are faster than the admin's replies. Right. Okay. Gerald Lotion, sir, you are totally not replying. But I replies, right? My number, I have got a new number. So I don't remember my new number. Let me check and give you. I have a new WhatsApp number. Yeah. Wait. That is 0.078 62 69 113 62 69 078. Right? Nikan di bindagat apa may salyo na nikan din nan ko mangkuhain ng din nila. Right. But the point is it gives a better internet quality. Hutch gives better internet quality than other networks. I hate Wi-Fi routers. They always lagging. Right. Only WhatsApp, and please do not call me, dear. I'm always in classes, so I'll not be able to answer your calls. But if you send me a WhatsApp message to this number, yeah, definitely I'll reply you. Right. And Tute's case, dear, you should send a message to the admins. They are arranging all the tubes. If you want, I can show you their video of their tubes room. There is a room to keep the tubes. If you want, I can show you a video of the tubes and the way the two admins are working. If you want, then you will say your my deepest sympathy for them. Right. So I think they will arrange everything. And sorry for the delay. Things will be okay. Let's give them some more time. Forgive them, right? Right. Okay. Shall we go to 600 pixels tube, dear? Right.
Okay, sir.
They are not so beautiful as you think, Isum. Right. Shall we go to shall we go to 600 pixels tube?
Okay, sir.
Okay.
Right. Can you see my screen, dear?
Yes, sir.
Yes, sir.
Right. What's the last question that we discussed? This tube. That's the last question. Let me go. Oh no, not 47. We didn't discuss that much.
12, sir.
Yeah. I think we didn't discuss the satellite questions, right? No, we didn't discuss them. This one, no. 12, eh? Question number 12. A tractor is also there. Motkovia's question is there. Question number 12. Did we complete this, dear?
Yes, sir.
Yes. Right. 11 completed. 12 completed. So let's go to question number 13. So if you do not have 600 questions, you don't worry, because I'll send you the images of 600 photos of 600 questions to WhatsApp group. So I'll send questions to WhatsApp group. So don't worry if you do not have the tute. And the other thing, I'm showing you the question, right? Right. Somebody unmute the mic and read question number 13 there. We have discussed up to 12. We have answered all the first 12 questions. Read question number 13 for us, one.
Two objects are connected by a light inextensible string, and they are moved on a smooth horizontal surface by a horizontal force as shown in the following. Question 1. Find the acceleration of the system. Question 2. Draw the free force diagrams of the objects and the string. Question 3. What are the tension forces acting at the end of the
Okay, very good. Thank you. What is the meaning of this term there? What is the meaning of this term? Light. What does it mean?
So it does not have a mass.
String does not have a mass. That's the meaning. Light string means massless string. Then you have another term, inextensible. What does it mean, dear? Inextensible.
does not stretchable?
Yeah, not stretchable. It means by applying forces, you cannot increase the length of the string. So what are the meanings, dear? Light means massless string. Inextensible means you cannot increase the length by applying forces. Got it? Right, let's give a try. So two objects are connected as shown in the figure. The first thing that they have asked is asked to find the acceleration. The objects are 3 kilograms, 6 kilogram, and the horizontal external force is 18 Newton. Let's give a try. Right, I'm going to erase the board. So if you want any more time to write the things, please take a screenshot. I'm going to erase everything that I have written on the board. So let me draw the figure. 600 questions tube. All the 600 questions are new questions. 600 questions tube. Page number 3. Page number 3, question number 13. They have given us two objects. Two objects are there. Look at board. They are connected by a light inextensible string, massless, unstretchable string. They are connected like this. They are pulled on a horizontal surface by a horizontal external force of 18 Newton. The masses are given as 3 kilogram and 6 kilogram. Please draw this figure here. Write the heading 600 questions tube. Use the normal theory note, right? You can use your theory note, no problem. 600 questions tube, page number 3, question number 13, and draw this figure. Right? Due to this 18 Newton force, the whole system, all the things are moved with an acceleration of simple A meter per second. The first thing we want to find the size of A. The first thing that we want to find the size of symbol A, acceleration. Draw it here, quick. Listen here, we have sent some tubes free of charge. We didn't take, but there's a small problem with the 600 questions tube. So let me show you the tube. See, this is the 600 questions tube. It is bigger than 2 CR books. That's the cases. See, if you check the size and weight, it's bigger than, you see, it's bigger than 2 CR books. So it takes a cost to print as well as it takes some money to post. But if you find, so therefore, and the other thing, and the biggest problem is these days it's difficult to print this one. Right? We have posted first, I think about first 100 I have given, and I have only few of these tubes, so we have to reprint. We have a small problem with the printing also. So please give us some more time. No, please give me some more time to send you this tube. Right. Shall we go to the next? No. Acceleration. How do you find the acceleration, Kuda? Somebody please give me a method to find the acceleration.
F equals ma.
Very good. To the entire system, to the Lian, look at board on right. To the system, to this direction. What have I done here, dear? I have indicated to which that I apply the equation. What did I do here? What did I done here? I have indicated to which that I apply the equation, and I have indicate the direction. Why should we indicate the direction with an equation? Tell me, dear.
So because it is a vector quantity.
It's a vector quantity.
Very good, because F is a force, a vector. Acceleration, it's a vector. When we work with vectors, when we deal with vectors, we must indicate the direction. That's the reason. If you consider this everything as
Because of
very good. If we consider everything as a single system, what is the only force acting on the system? This dotted line, the things inside this dotted line margin is said to be the system. So what is the only force acting on the system, dear? Somebody?
So the external force.
80
External force.
Yeah, what is it?
18
18 newtons.
18 Newton, 18
External force.
What is the total mass of the system?
9
9
kilograms.
kilogram.
9 kilograms.
Kilogram.
So 18 equal 9 times 8. Take 9 to this side. 18 divided by 9 equals 8. Therefore, acceleration is 2 meter per square seconds. 18 divided by 9 is 2. I know maths very well. I can divide 18 by 9. So acceleration equals 2 meter per square seconds. Write it. Write them all. Right. If we have written them, now we are able to draw the free body diagrams. Free body diagrams mean we mark all the forces acting on each object, even on the string. What is a free body diagram, dear? Free body diagram is a figure on which we mark all the forces. What is a free body diagram or a free force diagram? It's a figure on which we mark all the forces. Right. Look at board carefully. Do not write anything. Do not write anything. Look at board very, very carefully. Now, if we consider this 6 kg object, why is it moving to right hand side? Why is it moving right hand side with an acceleration of 2 meter per square seconds? Somebody unmute the mic and tell me.
because its force is in the right hand side. Greater
Again?
force.
Again? Yep.
Because its force is in greater force is in the right hand side.
What is that force, dear? What is that force?
External force.
External force. Because of the 18 Newton external force, this object is moved to the right hand side with the with an acceleration. Who has said us that a force is needed for an object to be moved with an acceleration? Who said it? Who said it?
Newton.
Newton, sir.
Newton had said that an object wants a force to be moved with an acceleration by his first law and second law. Right? Second law says F equals ma. Now, if I consider this string, why this string also move to the right hand side? Somebody unmute the mic and tell me why it is moving to right hand side. What are the reasons? There are two
Because
reasons.
it does
Yes,
not have.
actually there are two
So because
reasons.
it does not have a mass.
No, even it has a mass. Yeah,
Because of the external
The
force.
6 kg
what
object
are
gives
the real
force.
reasons behind it? Why it is moving right hand side?
The
Because
6
There is
kg
a
object gives
reaction
a force.
force.
The first thing, the 6 kg object is connected to the string. So when the 6 kg object is moving right hand side, is string will also be moved with it. That's the reason. Am I right? 6 kg
Yes, sir.
object is
Yes, sir.
connected to the string. When the 6 kg object is moving, it has to move the string also. Am I right?
Yes, sir.
Yes, sir.
The first reason is 6 kg object and string are connected. When the 6 kg object is moving to the right hand side, the 6 kg object gives a force of T1 Newton to the string. The string is moved due to this T1 force. This T1 force is given by the 6 kg object. Now somebody unmute the mic and tell me Newton's third law of motion.
Every
Every action has an equal and opposite reaction.
Every action has equal and opposite reaction. Every action means every force has equal and opposite reaction force. When the 6 kg object gives a force of T1 to the string gives equal and opposite reaction force of F1 to the 6 kg object. This T1 and F1 equal in magnitude, opposite in the directions. Opposite in the directions can be seen. Equal in magnitude means if T1 is 100 Newton, F1 will also be, if T1 is 100 Newton, F1 will also be, hey,
100 newtons.
100 Newton. They are said to be action reaction forces. Action reaction forces. Now, let's come to this 3 kg object. Let's consider this 3 kg object. Right. Somebody unmute the mic and tell me the reasons. Actually, there are two reasons for the 3 kg object to be moved to the right hand side with an acceleration of 2 meters per square seconds. Why this 3 kg object is moving right hand side? There are two reasons. Somebody please tell me.
it is
Because
connected.
Yeah,
Because
because
it is
6
connected.
kg object and string are connected together. That's the first reason. Why? 3 kg object and the string are connected. Second reason, three kg object and the string are connected. That is the first reason for the 3 kg object to be moved. Second reason.
String gives a
Yeah, when the string is moving to the right hand side, it has to move with the 3 kg object. Therefore, the string gives a force of simple F2 to the 3 kg object. So 3 kg object is moved by F2. F2 is given by the string. Now tell me Newton's third law of motion. Newton's third law of motion.
Every action has
Every
equal
action
and
and
opposite
opposite
Every action has equal and opposite reaction force. All the forces have oppositely directed force. So let me mark this force as T2. F2 given by spring to the object. T2 is given by object to the spring. They are equal in magnitude, opposite in the direction. Therefore, they are called action reaction forces. Action reaction forces. Right. Now, if F2 is 10 Newton, what should be the size of T2, dear?
10 Newton.
It should also be
10
10 Newton.
Newton.
In addition to all of these forces, another two special forces are acting on 6 kg object. What are the two forces?
Gravitational
Normal
force.
reaction force.
Gravitation acts
Yes.
Very good. Gravitation attraction force. Let me mark it as M1G Newton, and the normal reaction force given by the surface, let me mark it as R1. Similarly, there should be the same two forces acting on this 3 kg object. What are the two forces, dear? What are the other two forces acting on this 3 kg object?
gravitation action force.
gravitation and attraction force and
Gravitation attraction force M2G Newton and the normal reaction force R2 Newton. So these diagrams are said to be no free body diagrams. Why didn't I mark Mg for the string? Somebody please tell me. Why didn't I mark M3G Newton for the string? Why is that?
It is a light object, sir.
It is said that light
The string is the
light
light. The
object.
string no mass.
No
The string
mass.
does not have a mass, so there is no weight. I didn't draw an R force for the string. Why is that?
because
Because the string is
Because
not
it has no
on the
reaction, normal
surface.
reaction force.
The string is at above the surface. As it is not in contact with the surface cannot give a reaction force. Object is on the surface, so surface give a force. 3 kg object is in contact with the surface, therefore the surface is giving a reaction force. But the string is not in contact with the horizontal surface. Therefore the surface does not give any force to the string. So I didn't mark R on the string. Correct? So please draw the three figures. If you have any further doubts, please ask me. And never draw figures when I am explaining. Right? I'll give you more than enough time to draw the figures. Start here. While you are drawing figures, you can send me messages and ask doubts. Start. Once you have drawn the figures, please tell me, right? Send me a message saying that you have drawn it. So I think time is enough to draw. And if you are a new student, you must understand everything because I have explained everything from the beginning. But still, if you think you want to learn the missed sections, send me a message. I'll arrange some repeat classes, right? I am always support you if you really want to learn. Sometimes replies may be late, right? Netherlotion. Replies may be late, but I'll help you definitely. So if you think that you want additional help for the things that you have missed, if this is your first day or if this is your second day, so no problem, send me a message. I'll help you. I'll add some repeat classes, right? So I want to find this F2 and T2. To find F2 and T2, the easiest method is look at board. Only to 3 kg object. Please clearly indicate only to 3 kg object. Into the right hand side horizontally. Let's apply F equals ma. The only horizontal force acting on the F2 object is 3 kilogram. The only horizontal force acting on the 3 kg object is F2. F2 equal mass is 3, acceleration is 2, so F2 equals 6 Newton. Got it? Right. My Dadi's daughter is there. She is helping me a lot to teach you. Say bye. Okay, now. Okay, shall we please find 6 Newton? And somebody unmute the mic and tell me if F2 is 6 Newton, what should be T2, dear? Sorry, what should be T2, dear? You can't unmute. Ne? Wait. I'll give you help. Right. Right. Now, somebody please tell
6
me, and with the
Newton.
mic
6
can tell
Newton.
me.
Newton,
Six,
sir.
Yes, very
6
good.
Newtons.
Very good. But we know that F2 equals T2. So if F2 is 6 Newton, if F2 is 6 Newton, T2 should also be 6 Newton. So these T1 and T2 forces, these T1 and T2 forces are said to be tension forces in the string. Complete it here. Mark it. And the other thing is, I'll not stop online classes, right? I'll continue online classes until you go to the examination. And the other thing is, according to this present situation, we don't know whether we'll be able to start physical classes or not. The online, this Monday, this Tuesday night class, I'll not stop until you go to the examination. We'll continue all the online classes until your examination. Not only me, the math teacher and chemistry teacher will also do the same. So don't worry, right? Okay, dear. Now, how do we find this T1? Somebody unmute the mic and tell me. If we know F1, we can know T1. So how do we find this F1? Somebody please tell me a method.
Applying F equals MA only to 6 kg.
Very good. Only to 6 kg object. Only to 6 kg object. Let's apply F equal MA equation horizontally. I have indicated the object. I have indicated the direction. How many horizontal forces are acting on the 6 kg object? How many horizontal forces?
2.
There are
2,
two
sir.
horizontal forces, F1 and FEX. The resultant force acting on the 6 kg object is FEX minus F1. Equal mass is 6, acceleration is 2. Can you do the rest and find F1 here? Can you do the rest and find F1? Give a try. Try here. Right. Okay. Right. Right. Let me take this plus 12 to this side. 18 plus 12 comes this side as minus 12. Minus F1 goes to other side as positive F1. 18 minus 12 is 6. So F1 equals 6 Newton. Who got this answer? But we know that F1 equals to T1. Therefore, T1 is also 6 Newton. So what do you think about this T1 and T2 forces, Deep? T1 and T2 are the tension forces acting on the string. The names of T1, T2 tension forces. Now you see that T1 and T2 are equal. Both T2, T1, 6 Newton each. Remember that the tension forces be equal only when the mass is 0. If it is given that string is massless or string is light, then only the tension forces are equal. If the string has a mass, the tension forces will not be equal. We have discussed such a string with the mass this Sunday morning class, a past paper question 1990 level question. In that question, the connected rope has a mass. I think you remember that question. So the most important classes are Tuesday night class and Sunday morning class 9 to 12, and 9 to 12 a Sunday morning class, Tuesday night 8 to 11 class. So therefore, I teach Sunday morning and Tuesday night classes. Still I teach them free of charge because they are very important. But any matter is able to understand units and dimensions lesson. So therefore, when I teach units and dimensions measuring instruments lesson, I charge a fee because it's a very simple lesson. Any matter can understand it. Right, units, dimensions, measuring instrument. Right. Is that all? Do they ask anything further in that question, dear? Do they ask anything further?
No, sir.
What about the next question? What about the next question? Shall we give a try? Shall we give a try for the next question? Can you see my screen, dear?
Yes, sir.
Yes, sir.
Question number 14. Somebody unmute the mic and read question number 14 for all of us loudly.
A box of mass 20 kg is kept on a smooth horizontal surface. Another object of mass 16 kg is kept on the box. The two objects are connected by a light inextensible string, and the string goes over a smooth pulley. If a force of 6 Newton is applied on the box, as shown in the following figure, find the acceleration of the box.
Okay, very good. Please check whether you see that. Did you notice this term here? A box of mass 20 kg is kept on a smooth surface. What does it mean, dear? Smooth.
No friction.
No
No
frictional
friction
forces.
force.
No frictional force.
Very good. Another object of mass 16 kg is kept on the box. The two objects connected by a light. Light mean, what does it mean, dear?
No mass.
No mass.
Light means no mass. Inextensible mean?
Unstretchable.
Unstretchable. You cannot increase the length by applying forces. Right. Then goes over a smooth pulley. What is the meaning of smooth pulley, dear?
No friction.
No frictions.
No friction. If a force of 6 Newton is applied on the box as shown in the following figure, find the acceleration of the box. Now you see, dear. Now you see, there are no friction forces. So as usual, let me mark the tension forces acting on the string. Light string means if the tension force here is T Newton, what should be the tension force at the other end here? Here.
T newtons.
So same.
The string is massless, therefore tension force at the other end should also be capital T Newton. No friction forces are acting on the system. Got it? Right. I would like if you take a screenshot. And the other thing, please draw this figure. Please draw this figure with this T Newton and T Newton. Please take a screenshot also. And I have a question to ask. Right. If this object, this 20 kg object is moving to my your left hand side with an acceleration of simple a. If this 20 kg object is moving with an acceleration of simple a, right? What should be the acceleration of this 16 kg object here? Somebody?
Yes, sir.
Yeah, simple. You see this 16 kg object connected to 20 kg object. Very good. So if the 20 kg object is moving with an acceleration of simple a, 16 kg object should also be moved with the same acceleration. But what about the moving directions there? They are moving directions.
Opposite, sir.
Opposite. Opposite. 20 kg object is moving to your left hand side direction. 16 kg object is moving to your right hand side direction. Because of the string, they will be moved with the same acceleration. Because of the pulley, they will be moved to the opposite direction because you see the forces. So please draw this figure with the two tension forces and the accelerations. Draw the figure exactly like this and mark everything that I have marked. Draw the figure on your book there. Start. Draw it. I think you have drawn. So let me draw the figure on whiteboard. Right. If you want, please take a screenshot of the things that I've written on the whiteboard because I'm going to erase everything. So if you want, please take a screenshot. Okay, let me draw the boxes separately. If I consider this 16 kg box, it is moved by this tension force capital T. It is moved by this tension force capital T into this direction with an acceleration of simple a meter per square seconds. So only to 16 kg object to this direction, I apply F equals mv. So when you write this equation, it's better if you draw this 16 kg object separately. The only horizontal force acting on the 16 kg object is capital T. Its mass is 16. Acceleration is simple a. Let me mark it as first equation. So I would like if you write down everything. So this is question number 14. I know that you have already drawn the complete figure, but if you draw this separately, it will be easy for you to understand. So draw it there and write down everything. So today I'm so happy because my sisters, daughters are here. So I'm so happy today. Right. Let's do the same thing to the next object. Right. Look at board. If you consider this 20 kg object. Here, this time I draw only the horizontal forces because they say they have given that surfaces are smooth. So why should I worry about the R and mg and friction? So I just consider only the horizontal forces. There is a horizontal force of 6 Newton acting into my left hand side. That's the force of capital T Newton given by the spring into my right hand side direction. So only, look at board, only to 20 kg object to this direction, I apply the equation F equals mv. The only force acting, the force acting right hand side 6, force acting to left hand side capital T. So 6 minus capital T equal mass is 20, acceleration is simple a. Let me mark this as the second equation. Write this, draw the figure, write the equation. Here I have marked only the horizontal forces. Start there. Right. What should we do to find the acceleration, dear? What should we do? What should we do next, dear? What should be the next point? Hello? How do you find this capital T and acceleration? What should be the next
So
point?
subject the A.
Subject A.
Solve those equations simultaneously.
Solve the two simultaneous equations. How? What should we do next, dear? Yeah, we should solve
Subject
the
A,
simultaneous
sir.
equations, but how? Please tell me the method.
Instead of T,
1 plus 2.
Very good. Just add 1 and 2. What's your name, dear? What's your name?
2.
Yeah, let's add 1 and 2. 1 plus 2. Look at board. The first equation, only capital T. The second equation, T plus 6. Sorry, T minus 6 minus T. Second equation, 6 minus T. First equation, T. Second equation, 6 minus T equals first equation 16A. 16A. Second equation 20 times A plus 20 times A. T plus 6 minus T. 16 plus 20. Here. 16A plus 20.
36.
36.
36 is
Is it that much difficult? 36. What will happen to this plus T and minus T? T and this minus T, what will happen? Cancelled out. So 6 equals 36 times A because T and T cancelled out, plus T and minus T cancelled out. Let's take 36 to this side. 6 divided by 36 equals simple A. So simple A equals 6 divided by 6 is 1. 36 divided by 6 is 6. Unit is meter per square second. You must write the units with the answer. Then only you will get the, you will earn marks. Complete. And if you have any further doubt, just unmute the mic and ask. Or send me a message to Zoom chat. And the other thing, after many days, after so many weeks, I send you a PDF of units and dimensions note. Did you see it? Today I sent it. Daruwane?
Yes, sir.
yes sir.
Daruwanta
Yes,
hambuna
sir.
deka?
Yes.
Hambuna.
Yes, sir.
Yes, sir.
Apadikkada mama ewa units and dimensions note, right? A PDF with the correct page numbers. Okay, dear? Right. මේ ළමයි නිකමටවත් මට thank you කියලා reply කරේ නෑ ඒ උනාට. Hmm?
Thank you.
Thank you, sir.
sir.
Thank you.
Thank you, sir.
Actually, I created PDF 2-3 weeks ago, but I forgot it. 1 or 2 weeks ago, I created it, arranged it, but I forgot to send it to the groups. Welcome you all. Right. Okay, so shall we find the tension force also here? How do you find tension force? Give me a method. We found the acceleration of the system. How do you find the tension?
By
Substitute
Yeah, tell me, dear.
by substituting
A, sir.
By substituting the value of value of simple A, right? So normally we write it like this. We say by using the first equation. The first equation tells us capital T equal 16 times A. First equation tells us the tension force capital T equals 16 times A. So 16 times A is 1 over 6. 16 divided by 2 is 8. 6 divided by 2 is 3. Therefore, the tension force is 8 over 3 Newton. In the examination, you have to divide this 8 by 3 and give it at least with 2 decimal places. But for my questions, never divide, because I want to practice how to work with fractions, something divided by something. I want to teach you how to deal with fractions. So keep the answer as fractions for all of my questions. Complete it, dear. Complete it. What do you think about question number 16? No, not 16, 15 actually. Eh? Shall we go to question number 15?
Okay, sir.
Okay, right.
Okay, sir.
Right. So student have given me the permission. So I'm going to go to question number 15. Can you see it?
Yes, sir.
Right.
Yes, sir.
Okay. Yes, sir. I'll read the question. Two metal balls of masses 6 kilogram and 9 kilogram are connected by a light string. By applying a vertical force of 160 Newton to 6 kg ball, the system is moved up with a constant acceleration. The masses of the two objects, 6 kilogram and 9 kilogram. Find the acceleration of the system. Right. If you want, please take a screenshot and let me solve this problem. I'm going to solve the problem. You just look at board, because I think you in Sunday morning paper class also we discussed a past paper question very similar to this. Do you remember it, dear? Who joined to Sunday morning class and remember this question?
Yes, sir.
Yes,
Yeah,
sir.
similar question, right? Similar question. So here also, light string. Light string means no mass. No mass. Let me draw it. Let me draw the figure. But before that, if you want, please take a screenshot of a whiteboard, because I'm going to erase everything. So if you want, please take a screenshot. Okay, let me draw the figure, but in not in this format. So let me use the word system. System. System means everything. The system means everything. For example, if you want, you can see me as parts. Right hand, left hand, head, neck, body, and legs. Or you can see me as one object, a human. Even though my parents don't believe me, you can think teacher is a human. So, or you can consider as parts: one hand, second hand, head, neck, body, and so on. Or you can consider everything. You can take everything together and tell a human. So here I'm not going to worry about the ball here. I'm not going to worry about the ball there. I'm not going to worry about this. I consider everything as a system, and I'm going to write mass of the system. Mass of the system. Let me take this as capital M equals mass of the first ball 6 kilogram, mass of the second ball 9 kilogram. Therefore, the mass of system is 15 kilogram. Mass of the system is 15 kilogram. So I have indicated mass of the system by capital M. Therefore, the weight of the system. Somebody unmute the mic and tell me if the mass of the system is capital M. If the mass of the system is capital M, what should be the weight of the system? Somebody? Hello?
10 m, sir.
Around that.
So 10,
If
so
the
10
mass
into
of the
capital M.
system, listen carefully. If the mass of the system is capital M kilogram, what should be the weight of the system, dear?
Capital M,
Capital MG. Ayyo, capital M into simple G. The total force acting on the system is given as 160 Newton. 160 Newton. Under the influence of 160 Newton and capital mg force, do not forget to use capital M. Capital mg force, the entire system is moving up with an acceleration of simple a meter per square seconds. I am going to find this simple a. So for the question number 15, draw this figure with these dotted lines, indicate it as a system, and write the mass of the system as 6 plus k 9. So I'm going to consider everything together as a single object. The single object is said to be the system. Draw it. Draw and write down everything that I have written on the board. And how is our chemistry class, dear? Our Senanayaka sir's chemistry class, how was it?
Excellent, sir.
Excellent.
Great, sir.
So good.
Yes, any other comments?
Superb, sir.
Right. I'm
So
going to ask you a question. I said that he's the best chemistry teacher in the island. Am I right or wrong? Saumika Senanayaka.
You're
You're
right.
right, sir.
100% correct or not?
1,000 times.
100% correct, sir.
Right. What is his class time, dear? Saumika sir's chemistry class?
Thursday, 6.
Thursday 6 to 9.
6 to 9. What is the lesson?
Hydrogen.
Yeah, what is?
Hydrogen emission spectrum.
Hydrogen spectrum.
Hydrogen emission spectrum, right? Okay. So I have introduced the best chemistry teacher. So try to achieve a good rank. What about the trigonometry class, dear? Trigonometry math students. I'm talking about math students, dear. How was it? ළමයි trigonometry නැතුව maths වලට A ගන්න නම් හිතන්න එපා. ඒක මේ ආත්මෙ වෙන්නේ නැහැ. කෙලවෙයි ඈ. You must learn trigonometry lesson with the best experienced teacher, right? සෙල්ලමක් නෙමෙයි හොඳේ. මං කිව්වේ නැහැ කියලා නම් කියන්න එපා. Okay? Right. Yeah, there are many good teachers, but for the students Kandy, Kurunagala, Mavanalla, Kagala, Matale, Nuwarelia, for those areas, the best is Anandi Langakon, sir. That's why I asked you to join to his classes, right? So trigonometry is very important. So please give your maximum effort. So those days we used a huge book for trigonometry. I don't remember the name of the author. And if you do it, that book, because Anansa is doing that book, you talk to him and ask the name of the book. So it's a huge one, right? This much of size. You have to do a lot of things for trigonometry, right? Right. How do you find this acceleration? How do you find the acceleration? Look at board. To the system, vertically upward, we apply the equation F equals ma. The upward force 160. What is the downward force? Somebody please tell me. What is the downward force? Capital mg. What is the downward force, dear?
150 Newton.
What is this?
Sir, 150.
Capital MG.
Capital MG,
The
sir.
downward force is capital mg. I wanted it. Capital mg. Mass is capital M. Acceleration is A. I wanted to indicate capital M. Capital M is the total mass of the system. Right. 160 minus capital M, 15. G is 10. This is 15. Acceleration is simple A. 160 minus 150 equal 15 times A. 160 minus 150 is 10 equal 15A. So if you take 15 to this side, you will get 10 divided by 15 equals simple A. So simple A equals 10 divided by 10 divided by 5 is 2, 15 divided by 5 is 3. So acceleration is 2 by 3 meter per square seconds. Complete it. Is everything clear?
Yes.
Uh, can you give a try to do the rest at home, dear? Can you try to
Okay,
solve the
sir.
rest of the question at home?
sir.
Right, so I'll send you the photos of the question to your WhatsApp groups of the 600 question tubes until I print and give you. So it will take about some more days to reprint because the first printed 100 tubes over. Right, so if you have written everything, that's enough for today. But if you won't write, I'll wait here and try the rest of the questions at home. Good luck. See you. Bye.
Thank you, sir.
Thank you,
Bye.
sir. Good night, sir.
Thank you.